All right. So the grades are not ready yet for the exam, but I would like to hear from you. What did you think of the midterm? Fair. Okay, I guess everybody
Yeah, it
was.
seemed to.
Okay, very good. I mean, I started grading it. It looks pretty good so far, so I'm happy with how you guys did. So I told you that K-maps might have been on the exam, but they weren't, right? But of course, you are responsible for them. So the assignment. Oh yeah, by the way, the assignment that I assigned and then I went over it and then I told you to submit it later. So the link is there. You can submit it now if you haven't already. Just make sure you submit it. But I'm going to go over it really quickly again, just to freshen up your understanding of K-maps. Right? Then I'm going to assign, well, then I'm going to explain to you an even more complicated K-map, what is called a 5-variable K-map. And then I'm going to assign a homework assignment for tomorrow based on that. And that is going to be, I think, fairly challenging. And after I'm done with that, we're going to have an unannounced quiz. And the unannounced quiz is going to be on what we have learned about K-maps so far, right? The 5-dimensional K-map will not be on the quiz. Okay, so that's the plan for today.
Question, Professor. The homework extended right now, that's for homework 11 or what?
Basically, there were a couple of people emailed me who had special situations. Whatever homeworks you haven't submitted, please submit it in there. But yes, it's intended for homework 11. Yeah. That's right. Right. The homework 11 is in the slides for class 11. And so let's take a quick look at that. Wasn't there? It's the homework that I have gave you the solution to. I just wanted you to do it on your own, and actually I plan to go over it again very quickly right now. So let's just do that, right? And actually the link will stay live, I think, until like 2 p.m. So if you haven't done it yet, you can just basically write it out yourself as a review, but that will be after the quiz. Right, so let me go over it. Right, it's actually homework 11, but it's called 13 here. And I already went over it, and I'm doing it right now as a quick review for the quiz that is coming up. Right. Okay, so let's load this in. Right, so yeah, this is something that we learned last week, but then you were preparing for the exam, and there was exam. So I just will go over it very quickly again so that you still have plenty of time to do the quiz. And then I'll explain the 5-variable K-map.
Say, Professor?
Yeah.
Sorry, I joined a little bit late. I was having some audio issues. So we have a quiz today or next class?
Yes, the quiz is today. Yeah. Okay. So the quiz is today. The quiz is on what we learned in the last week, right? K-maps. And in order for you to do well on the quiz, I'll just very quickly go over, the homework based on that topic, right? So if you remember, or you should remember, that a function can be represented by just a sequence of minterms, right? And it can be represented either just by numbers or by the actual minterms. And you can go back and forth, and you can do that through a K-map, right? So you draw the map where areas of the map represent the variables in the function, right? So this particular function has 4 variables, x, y, z, and t, right? It will have the K-map will have as many cells as 2 to the power of 4. And in fact, you can double check if the function is represented by numbers, right? The highest number should be greater than the power of 2, 4 minus 1, greater than 8, but less than 2 to the power of 4, but this is 16, right? So it all has to match, right? Then you break up the map, right? And for each variable, the map should be broken up in half, right? For example, for x, we have this half is x, and of course the other half has to be its complement of x. With y, we're doing it horizontally, y, and then below complement of y. Right? With z, we have to get tricky, right? So we do it, we break it up, vertically again, I guess, and z is the middle strip, right? It's sort of parallel to x, but shifted, right? And then the complement of z has to be on the sides of it. But if it were just a three-dimensional, if it's a three-dimensional map, it's a donut, right? Effectively, so this complement of z and this complement of z touch, right? So when we look at implicants, right, we see that this one of these implicants sort of like goes around. And then with t, we do the same thing, right? It's sort of parallel to y, but t is the middle band here, right? And complement of t is the rest, meaning that these two strips at the top and the bottom, and this three-dimensional donut connects there as well. So that the reason for having all of this geometric gymnastics is to make sure that each domain, right, for each variable, whether it's true value or complement of that variable, within themselves they have to be contiguous, right? So, for example, z complement of z looks like it's broken up into parts, but not really, right? Those two parts connect in the back. Same thing for t, right? So when we look at 5-variable K-map in 10 minutes, that will become even harder, but you have to stay with it. Okay, very good. So now once we put our minterms, right, as ones on the map, or these numbers as ones on the map, now we want to cover them, all of them, with the smallest number of largest implicants, right? And the implicants have to have either linear or rectangular, or square, right? But they have to have either 2 or 4 or 8 powers of 2 of minterms encompassed in them, right? So we found the y is there. I'm sorry, let's give them names. It's the b is the red one, the a is the green one, the blue one is the c, and all of them, right? All of these three a, b, and c prime implicants, they encompass 4 minterms, which is cool. And the largest implicant that we could come up with that encompassed this minterm in the square 0, right? It's d, right? And it goes around and it encompasses 2, which is okay, right? But let me ask you real quick: is d an essential prime implicant or not? Because it is smaller than all of the other ones.
It's essential because it's the only one that gets
it's essential because that's right, correct. It's essential because without it we cannot cover the prime minterm 0. Okay, so there we have it. We have our 4 prime implicants.
And then just keep doing questions.
Professor, I have a question. So how did you, I understand how you placed the numbers, but I just don't understand how you decided what was 5, what was 7, what was 15, 0, all of that.
Okay, hold that thought. And there was another question from a female student. Hello? I think it was Anna or Stephanie. No? Okay. So the question, a good question from a student, and some of you might have the same questions. How do we get these numbers, right? So when we look, for example, at this midterm, complement of x, complement of y, complement of z, complement of t, right? We can just simply, find it, right? Find it on the map, right? So if x is here, then complement of x will be here. So wherever it is, it's going to be in the right half. Okay, fine. Then it has to intersect with complement of y. Okay, very good. So if y is the top part, then complement of y is below, right? So now we have intersection of complement of x, complement of x and complement of y. So now we know that it's going to be somewhere in this bottom right quadrangle. So everybody is still with me, right?
Resources-wise,
Yeah.
like.
Okay, I hear female students' voice going in and out.
Oh, I think that was my sister in the background.
Okay,
Yeah.
all right. Okay, so let's keep our microphones off. Okay. So we got it. The bottom right quadrangle. We keep going. So now it has to intersect with complement of z. All right. So if z is this middle strip, a complement of z are those vertical strips on right and left. So this one on the left will not intersect with what we have, but this one does. Right. So complement of z will intersect with this, square, and now we have only two cells left. Right. And now it's complement of t, right? So this is t, up and down is complement of t, right? So when we intersect this complement of t with what we had there, we're left with a single square, which is 1, okay? I mean, this is the square.
I have one more question then. Are we?
I haven't answered it yet.
Okay.
I've asked, hold the thought.
Okay.
I asked for it, answered half of your question, right? So this is how we can come from minterms to the exact spot on the map without even worrying about numbers, right? But you should be able to do it with the numbers too, right? So that's the second. I mean, you can always do it, convert it back and forth, but let's look at how to do it with numbers, right? The idea is that each minterm, right, represents all of the variables in this function, right? So this particular function is a 4-variable function, right? So each minterm, will have all 4 variables or 4 literals, right? And we always want to put them in the same order. We decide on some alphabetical order, and we'll, always have them in the same order. And when we do that, we can represent each literal by a digit, right? That means that, binary digit, of course. It means that each minterm can be represented by a 4-digit binary number. And in that representation, whenever we have a true value of variable, like here, y and z, those digits are going to be 1s. And whenever we have a complemented value, like complement of x and so y and t are true values. They're represented by 1s. And complement of x and complement of z are the complement values, and they're represented by 0s, right? So that means that this term can be represented by 0, 0, 0, 0, and this one can be represented by 0, 1, 0, 1, okay? And this one can be represented by 0, 1, 1, 1. Everybody's still with me, right? If you're not, or the student who asked me last, tell me if you're okay?
Yeah, it's Mohammed. I understand so far.
Okay, good. So if this is 0, 0, 0, 0, well, what is it? Like if we convert it back to decimal, well, it's 0, right? It's this one. All right, how about 0, 1, 0, 1. So binary 0, 1, 0, 1. What is that in decimal?
It's 5.
Yep, there you go. There is 5. And the next one is 0, 1, 1, 1.
Okay.
That's 7, right? And we go all the way to the back, and we'll have as many numbers as minterms, and each number represents a minterm like that. And of course, you can go back, right? So let's try to go back from 13, right? So 13 in binary is going to be 8 plus 4 plus 1, right? So it's 8 plus 4 plus 1. So it's going to be 1, 1, 0, 1. Okay? 1, 1, 0, 1. So who can tell me, well, I guess without looking at the thing, what minterm would be 1, 1, 0, 1?
It would be
917,
X, Y,
6,
not
7,
Z, and T.
3.
That's right.
Yeah.
Turn off your mic. So the student correctly said 1, 1, 0, 1 will be X, Y, complement of Z, T, right? So this is just a reminder, refresher, how you can go easily back and forth between these different representations of a Boolean function. Now, all of these representations are fully equivalent, right? So these are unequivocally the same, right? And the K-map also, right? So what we see on this page right now is 1, 2, 3 equivalent representations of the same Boolean function. Okay, so we have 4 prime implicants, but A is not essential, right? So B is essential because it covers 7 and 5, and nobody else does. C is essential because it covers 10, and nobody else does. But A, whatever A covers, B and C cover, right? So A is one of the prime ones, but not essential. So here's another representation, equivalent representation of that function through the implicants, right? The way we named them. So B plus C plus D, right? And of course, now we want to come up with yet another representation, which will be the minimal form, right? By just converting back the B, C, and D into the variables that they imply, right? So implicants imply. So when we convert them back into variables, B becomes Y and T, C becomes X and complement of Y, and D becomes complement of Y, complement of Z, and complement of Z, and complement of T. Questions?
Is it okay if instead of writing it the way you did, the K-map with the placement of X, Y, Z, and T, is it okay if I use zeros and ones and then I use like X, Y, Z, T in my equation? Because I have an easier time writing it out that way.
So where would you put the zeros?
Like the top left box would be 0, 0, and the one to the right of that will be 0, 1, and then the one like I guess I could show you a picture, but I don't know how to do
Well,
it.
I think I understand what you're saying.
Yeah, I've done it for all the homeworks and it works. I just have an easier time doing it that way.
I understand what you're doing, and I'm glad that we should make connections in our mind, and it does work for you, but we're learning the conventional way of doing it. So I think that you should absolutely use this device that you came up with, but you also have to be able to convert it to all of these forms, right? And unfortunately, the homeworks have to be done this way, right? Why? Not because I'm just such a stickler. It's because this K-map has to correspond to these midterms, right? And then also to the numbers. So what you're doing is sort of using that binary number, and you're just directly putting the binary digits rather on the map. But again, I'm glad that it works for you, but you now have to be able to transition to the midterm. Okay.
Right. The way I do it, I do write out the midterms the way you want it as well.
But do you write out X, Y, Z, and T
Yeah,
on the map?
but they're not positioned the way you have them. I kind of it's really hard for me to articulate. But
You know what? Email me a picture of this afterwards, and I'll
I'd love
look
to.
at it. But just for everybody, right? The idea of contiguity of these domains, right? That's very important. Because, for example, this map, it could be just rotated, for example, right? Or I just could have come up with all different letters, different 4 letters, right? And that's fine, right? As long as I just keep them consistent. And whatever orientation I decide for this map, I can keep turning it. Once I decide it, I freeze it in that position. In any case, so the last thing is that I want to review here right now is related to that homework is going from names of the essential prime implicants here to the terms that they imply, right? So what we notice here is that B and C imply products of 2 variables, and D implies product of 3 variables. Why is that? How do I know that? How did I come up with that? Who can tell me? The longer you take to answer my questions, the less time you have for the quiz.
Could you just repeat the question, please?
Yeah. So B. So I have a sum of products, right? The implicants represent products. B here, represents product of Y and T. C represents product of X and complement of Y. And D represents the product of complement of Y, complement of Z, and complement of T. So I'm asking you, how do I know that B and C represent products of 2 variables and D represents product of 3 variables?
Because
yeah.
So because B and C cover 4 elements within the table, and D covers 2.
Yes, correct. Is that Anna?
Yes, this is Anna.
Oh, okay. All right. So let's take a look at C, right? So correct. It covers. So how can we go from C, right? It covers this bottom left corner. How do we go from that to product of Y and T?
I don't know if there's a more official way to do it, but I just look at which portions of the K-map are completely contain the prime implicant. So like for B, it's completely within Y and T and covers both X and X prime, so we can ignore that part, and covers both Z and Z prime, so we can ignore that part. So you just have the Y and T.
So that is exactly the way we want to do it, right? So this is correct. So I guess I asked about C, but let's look at B. So right, so B. Oh, I guess I did ask a question about it. Yes, let's look at B, right? B. There it is. It's this red shape, right? And it covers these 4 min terms, 1, 2, 3, 4, right? So it's 4 out of these 9, right? So it covers 4 of them. It's the 13, 15, 7, and 5. So it's 13, 15, 7, and 5. Okay, so let's look at them. Looks like they lay entirely, right, within the Y domain. but none of them lay within the y prime domain, right? That means that they cover the y. So y is going to be y, but not complement of y. So it's going to be y, right? So that's going to be one of the variables. They also lay fully within the t, right? And none of them is within complement of t, right? Which will be top and bottom, right? That means that it's t, but not complement of t, right? So that becomes the second term in the product. Okay, but what about x and z, right? So this implicant b covers all of x and all, or intersects with all of x and all of x prime, right? Which means that in order for that product to be true, it doesn't matter what x is. X could be true value, 1, or could be complement, false value, or complement, which is 0. Whether or not x is 1 or 0, it's going to be 1, right? So we could have said product of y, t, and then in parentheses, x plus x prime, right? But that's one solution. And then we can have in another parentheses, y, or in parentheses, x or x prime, which is 1. And then the last term in the product would be in parentheses, z or z prime, right? Why? Well, let's look at z. So this prime implicant b intersects fully the z and the z prime on the sides, right? So 15 and 7 cover z, intersect z, and 13 and 5 intersect z prime completely, right? So again, for this first product, z could be either 1 or 0, and the product is still going to be 1, right? So that means that x and z are not part of this product. Or rather, they don't affect it. Any questions about this? Okay. So let's review this very quickly also. Again, we have our 4-variable K-map that you should be comfortable with, you know, x's, y's, z's, and t's, right? Now we convert our function. This is a different function given to us. And each of these represents a mean term, and each of them represents a 1 on the map. You know, if it takes you a little longer to do that, that's fine, right? So once we have all of the ones on the map, now we're going to look for the large implicants, right? So we have A, which is all vertical, implicant of 4, then B, also implicant of 4. Now we still need more, right? Because we need to cover 7, 5, and 1. So to cover 7, we pick this implicant of 2 terms. To cover 5, another implicant of 2 terms, and to cover 1, another implicant of 2 terms, right? So we have 1, 2, 3, 4, 5 prime implicants. I'm going to tell you one of them is not essential. Which one?
C.
Okay. Or which other one is not essential?
D.
D, right? E, I think, is always essential, right? So either C or D, right? I don't think that we can. Yes, you're right. The student is right. I missed it. Yeah, we have one more prime implicant, right? F, that goes around, right? So eagle eye. Because this thing connects in the back, and we can have another prime implicant, right? And turns out then either C or D or F may not be essential, right? So that means, right? So that only leaves A and B as essential. But then we'll still need some of the non-essential ones. And because we have different variations here, different possibilities, that means that there will be multiple minimal forms. Right, so when we came up with the C's, the D's, the E's, and the F's, right, we exhausted all possible coverings. And then we look at combinations of those, right? So, for example, if we look at 7, it's this one that is covered by C and D, right? To list all possibilities, let's take one of these minterms, 7, covered by C and D. It can only be covered by implicants C and D. Okay, so either C or D must be in the minimal form. So we know that A and B have to be, but then of the remaining ones, either C or D has to be in there, right? That means that we can split the possible minimal forms into 2 cases. One case will contain C, the other one will contain D, in addition to A and B. So the first case is we have A, B, and C. So if we have A, B, and C, that determines which other implicants we want to use, right? If we have A, B, and C, we'll probably want to use E, right? Okay, this is a minimal form, right? So these 4 prime implicants cover everything, right? We don't need D and F. But in the second case, right, so what it has here, it has some kind of 2 multiplied by size 2 implicants. Okay, it's the C and the D. Okay, so now the second possibility is if we don't use C, but we use D. So we'll have A plus B plus D. But let's take a look at it. We have A, B, and D. And then we have one more 1 to cover. It's this one, number 1, square 1. And this one can be covered either with E or with F. We don't need both of them. And that gives us 2 more minimal forms, right? So we have 3 minimal forms here. Okay, any questions about this? Okay, no questions. You know, and of course, you know, these. Okay, and I guess we covered this. This is a reminder. So now, let's not look at the homework just yet. Let's look at this slide. So this is sort of the only new thing that I'm introducing today, and that is a 5-variable K-map. So as the number of variables increase, these K-maps become harder and harder to follow. And 5 is the highest number of variables that we're going to look at here. So effectively, it's some kind of 5-dimensional structure, right? And already it's really hard to imagine, but we're going to try, right? So theoretically, these K-maps can have as many variables, as you want, right? But then the number of intersections, or these little squares.
Question, Professor. Is a 5-variable K-map 2 4-variable K-maps combined?
Yes. Yes, good. But I'm getting there in a second. Yes, that is absolutely correct. So the number of these intersections or cells, or whatever you want to call them, little squares, will be 2 to the power of number of variables, right? So For example, a 4-variable K-map has 16, right? 2 to the power 4. 5-variable K-map will have 32 squares. It's possible to draw a 6-variable K-map. That one would have 64 squares. And drawing squares is not hard. What is hard is to imagine its topological shape in multiple dimensions. And as the student just correctly pointed out, the way we do a 5-variable K-map is we start with a 4-variable K-map. So our 4-variable K-map has A, B, C, and D, right? So if this is A and A prime, then we have B and B prime. Then we have C and C prime on the side. I'm only looking at the left half of the sign. And then for D, it's the middle stripe. It's D and then D prime top and bottom, right? So that's our good old 4-variable K-map. To make a 5-variable K-map, we take a mirror image. We don't copy it. We take a mirror image. Imagine like a book unfolded that way. So we have, let's say, the original K-map here, and its mirror images on the right. Okay. And we say the whole old K-map of 4 is now going to be the true value of E, this whole big square. And the mirror image is going to be, anti-E is going to be complementary. That means that now we need to figure out what happens with A, B, C, and D, right? So it should be fairly intuitive that, where the spine of this book is, right, this double line here, the A primes here will connect, right? They connect here. But also, imagine that this book is sort of like glued, the pages are folded back and glued there back. And this A and A here connect in the back. But it's sort of worse than that, right? Because not only do they need to connect in the back, they also need to connect in the middle. So it's hard for me to even imagine this five-dimensional shape, but it's going to have some sort of intersections within it, right? So, for example, this square is obviously contiguous with this square and with this square, but also with this square and this square, right? So I'm going to go over this again tomorrow, but this is the idea, right? So this will affect the homework that I will introduce in a second.
I have another question, Professor.
Go ahead.
So which part of the map encompasses E prime? The entire right side?
That is correct. Let's wait for it to come back. Yes, the entire right side is E prime. The entire left side is E, and that's pretty straightforward, right? For each of the variables, half of the squares have to be true, and half of the squares have to be complement for that variable, right? And then the hard part is to arrange so that we have intersections of everything, right? That we have all possible, we have intersections for all possible minterms, right? So in this case, with 5 variables, if that function is a tautology where it has every minterm, it would have 32 minterms, right? So we should have squares for 32 possible minterms, right? And then, of course, in fact, only some of them are 1s, and those are the ones that will have 1s in them, right? The other ones will be empty. And when we had pure variables, it was easier for us to imagine some kind of shapes where the domains are contiguous. So for example, here, it's easy to see how E's are contiguous, right? So we have like a big chunk of E's and a big chunk of E primes, and that's it. and all of the e's are together and all of the primes are together. And I suppose and then it becomes harder, right, with other ones. So for example, let's look at the D. With D, it's not bad, right? All of the D's are this long stripe here, going from left to right, right? But D primes are split into two halves, top and bottom, right? And we've seen that before. And now we have to imagine that it connects in the top and bottom, connect in the back, and left and right can connect in the back, right? And then so that was D. Like, how about C, right? With C we have this area and this area, and we need to imagine them connecting, top and bottom. And then for C prime, it looks like 1, 2, and then these two in the middle. And again, all right. So this is as far as we'll go with 5 dimensions. All right. So you're going to use this map for the homework that I'm going to assign in a second. So let's look at the homework. So homework will have 3 parts. It's homework 12, even though the number is 14 here. So you're going to minimize the functions below using the K-map method, right? That's for 1, 2, and 3. So the first function is this one. So this one is fine, right? Only has 3 variables. That's going to be easy. No problemo, right? It's, instead of, notice though that these A, B's, and C's do not represent implicants, right? These are just names of variables. As I told you before, we can name our variables anything we want, and here we're naming them A, B, and C. That means that when you're looking at the implicants, you will have to name them something else. You would have to name them, I don't know, X, Y, Z, or PQR, whatever you want, right? But yeah, it's just 3 variables, okay? So this K-map will only have 8 squares. All right, next one. You need to minimize this function. So let's take a look. This function has min terms going all the way to 29, right? So who can tell me how many variables does this function have?
5, at least 5.
Well, at least 5. Well, let's just say 5, right? How did you come up with 5?
2 to the 5th is 32, and we have our max number is 29.
Yeah, right. So our highest number representing a min term is 29. If we only had 4 variables, the most we could represent would be 16. But actually, if we start from 0, 15. But to get to 29, we need 5 variables, which allows us 32 different min terms, so from 0 up to 31. Right? So the student is correct. I do ask you to just say your name, before you speak, so that I know who's talking. Okay, so yeah, we'll have 5 variables, so it'll be a hard one, right? Again, note that the variables are named ABC for both questions, right? So like for this homework, keep the A, B, C, D, E. For question 14.2, I'm also giving you the K-map for 5 variables on the separate slide that's behind, and I already posted it on the page. So I posted both the slides and the homework, and also on Gradoscope, so you should start working on it right away while it's still fresh in your memory after the quiz. So that slide is sort of like helping for the homework. So use that map, right? Don't invent your own. Use that map. Now note that the K-map for 5 variables is formed by putting together, like a book that opens, 2 adjacent 4 variable K-maps for A through D, right? So each has are 4 variable K-maps, A, B, C, D, and together the 2 pages will make E and complement of E. Be careful with adjacencies. Note that the prime implicants can only have a size that is a power of 2, right? So that you remember that. Okay. And of course, the prime implicant of size 1, though technically possible, it's like really not very useful, right? Because it's just a single min term, but technically allowed. Right? You really want to look for 2, 4, 8, 6, etc. The only way to see if an implicant can be formed is to express it as a product of literals, right? So 1 would be a product of all 5 literals, 2 or 4, in this case, yeah, okay. In the case of 5 variables. The only way to, express literals, and then conversely, try to see if the product of literals corresponds to an exact implicant, right? As I showed before, you can go back and forth between different forms or different expressions. So that is the second half, right? The third one, and the fourth one, sorry, it's 4. We have this function, right? Goes all the way to 31, so that means that it will also have a 5 variable K-map. And here we have this new thing, 2 through 7, right? What does that mean?
Is it just 2, 3, 4, 5, 6, 7?
Exactly, yeah. So it has many min terms, so there's going to be lots of ones. All right, and then in the fourth one, we have a form, a standard form, not canonical, of a function. I see at most these terms are products of 4 variables. Can somebody tell me how many variables in this function? Is it a 4 variable function?
I believe it's 5.
Yeah, it's a 5 variable function. Alas, this one also will need a 5 variable K-map, right? So, in a standard canonical, we would just have a bunch of min terms. Each of them has all 5, but this is simplified. Still a sum of products, but the products are shorter, so this was some kind of simplified form. But you can go from it, right, and find. So basically, you have to expand it onto the K-map and then find all of the minimal forms, right, for all of these 1, 2, 3, and 4. Basically the same way as we did the previous homework, but now it's just harder. Okay.
I have a question.
Go ahead.
How do you chart the midterms with only 3 variables? Since there's 5, how do we know where it goes?
Well, good question, right? Or even with when you have only 4, right? So for example, I have here. How about this? Let's look at the second term here. It's complement of A, complement of B, complement of C, and complement of D. How do you know? The student is asking Stephanie, I think, and it's a great question. Like, what do you put on, on the map, right? Because if it had all 5, you could just say, oh, it's, 0, 0, 0, 0, and it goes wherever it goes, or you could say, if you didn't remember where the numbers were, how would you start? How would you go about it for the A prime, B prime, C prime, D prime? Right? Let's try to put it on the map. All right, well, A prime is this area. So that means that whatever we're putting on the map is going to be in this area, right? The middle square. As soon as it becomes confusing, just start talking, start asking a question. Right? So yeah, so it's going to be whatever we're putting. And look, if it were a prime implicant, we would be putting a single one. Whenever we have I'm sorry. If it were a minterm, right, which would have all 5 variables, that means that a single one would go on the map. But whenever we have these terms that have fewer than all variables, right, what does that mean? Does it still mean that we'll put a single one or not?
There could be more than one.
Yeah, in fact, if you have a 5 variable function, and you're looking at a term that has only 4 variables, so 5 minus 1, that means that 2 ones will go on the map, right? When you have an even shorter term, means that 4 ones will go, right? If you just had B and D, then 8 ones would go on the map. Right? If you had just E or E prime, then 16 ones would go on the map. Right? But as it is with our term here, it has A, B, C, A prime, B prime, C prime, D prime. All right, so A prime is going to be here. Okay, now B prime. Okay, so all of that is B, right? The whole top half. So the whole bottom half is B prime. So that means that whatever we're putting on the board is going to be where B prime intersects A prime, which is this rectangle that I'm circling right now. Okay, now we'll look at where C prime is. And this is, there is C prime here and C prime here on the sides, but they don't intersect what we want. But this middle stripe of C prime intersects A prime and B prime. And now we went from this to now smaller square here. Right? This square is the intersection of A prime, B prime, and C prime. And if D prime weren't here, then we would put 4 ones in there, right? But we also must intersect it with D prime, right? And D is the middle stripe, and D prime is top and bottom. So this little square intersects with D prime here, and that means that you're going to put 1 here and 1 here. Does that make sense? So these shorter terms, right, shorter than 5, represent some kind of prime implicant, right? And this may or may not be a minimal form itself, right? To know for sure, you want to put all of the ones that these implicants imply, right? And each one would represent a minterm. But you're not looking for the minterms. What you're looking for is, once you have all of the ones on the board, what is the smallest number of the largest prime implicants that can cover them? And then you will go back to a hopefully more simplified form.
Yeah, it makes sense. Thank you.
Very good. And realize that whenever you ask a question, there are 30 students in this class. There is more than one other student who needs to hear the answer to that same question. So I'm really grateful for people who ask questions. 2 people.
Question. So we follow the same method for the first question as well, except the first question is a 3 variable K-map.
Yeah, the first question is an easy one, right? You don't need that huge K-map. You need it's a small K-map that only has 3 variables. But yeah, you do the same thing. Yeah, the principle of K-maps is the same no matter how many variables it is, and it's quite simple with 3, and it's a little harder with 5. Okay, other questions? So really, this is the only new thing that we covered today, right? So there was a review, and now you're ready for the quiz. So I'm going to go through it or over it with you. So let's all go to Gradoscope. Quiz 2.1 should be there. And let's start it together. And I'll sort of like walk you through the questions. And you have plenty of time. Almost 40 minutes. So should be a good amount of time. Okay, so there is two questions, question 1 and question 2, and they have sort of, actually, sorry. Yes, there are two questions, question 1 and question 2, and question 1 has 2 parts and question 2 has 3 parts. Okay, so let's look at question 1. We want to consider this Boolean function. So right away, just tell me how many variables does this function have?
4.
4. Okay, so good. You don't have to deal with the 5-dimensional K-map on this quiz, right? 4. Okay, cool. So you consider it now. Draw the K-map and then find all prime implicants, right? So you're going to take a little piece of paper or a piece of paper, draw the K-map, and then circle the implicants and give them names like A, B, C, D, whatever, right? And then you take a picture of just that thing and you upload it here. That's 1.1. And 1.2, based on this K-map that you just drew, determine all minimal forms of F, right? So that should be like really straightforward. Now you already have your prime implicant circle. Now you can just, see if there's going to be at least one minimal form, and maybe it's just one, or if there's more than one, you'll be able to determine a minute from the prime implicants that you circled, well, that's what we just reviewed. Okay. And then for question 2, it's actually similar, right? Now consider another function. It's called capital F, obtained from the previous function, right? By adding just one term corresponding to 14. So if little f has all of these min terms, the big F has all of them also, plus one more, plus this one. So it's going to be one more one on the map. All right, so we'll look exactly the same with a single additional one in the square somewhere in there. Okay, so that's the new function. 2.1. Just like for the function above, draw the K-map. It will be exactly the same K-map with another one, but just draw it again. Draw it separately. It will be exactly the same, but with one more one. And now you find all the prime implicants for F. So even though the K-map is almost the same, right? Because of this additional one, the implicants might change quite a bit, right? So now you circle the new prime implicants for this new function, and now take a picture and upload it here. Okay, then 2.2. Based on this new K-map that you just made, determine all the minimal forms of that, right? So they're, similar. 1.1 and 1.2 is similar to 2.1 and 2.2. But there is one more question, 2.3. Explain how the solution changed when the function had just one additional min term, right? This is not a general answer. This is an answer in this specific case, right? So in your own words, in plain English, just say, oh, because of this additional one, different implicants, right? So just a freestyle response, like a little essay, the paragraph. Okay, and that's all. Okay. All right. So, there is a lot of steps. I don't think it's particularly hard, but you just have to do all of the steps. You have to pay attention not to make mistakes. So take your time. You have about 35 minutes, 34 minutes. Okay. I'll stay on if you have any questions. But I will stop sharing the screen and I will stop recording.